Hello guys, Assalamualaikum warahmatullahi wabarakatuh and a very good day. So today I'm going to teach you how to plot the cyclic voltammetry at different scan rate. So this is the example how you're going to plot the CV at different scan rate. In this case, we are using from 5 millivolt per second to 100 millivolt per second. Okay, so what we're going to do, I'm going to do the calculation and shows you the results. And from this graph, how we're going to convert into the bar chart. So from the bar graph, you can see the trend increasing the scan rate, the specific capacitance will decrease. Okay, let's go to the Excel. So what you're going to do first is you need to plot the CV at different scan rate. Okay, you need to have the software. For example, you are using Nova or Versastat or Gamry. You get the data first at 5 millivolt per second, 10, 15, 20, and so on until 100 millivolt per second. So then you need to copy the graph, for example, this graph, and open your origin. So when you open your origin, so for example, I already plot here. Okay, so when you open your origin, you paste your data. Okay, you need to paste your data like this one. 5 millivolt per second, and what you're going to do is you're going to plot here. This is the voltage or potential window, this is the current, and this is the current density. Okay, first of all, to get the graph you need to plot voltage and current density. So you just control here and just click here, so you can plot the graph for 5 millivolt per second, for example, like this one. Okay, this is the graph at 5 millivolt per second, and you can do so for the rest of the graph. When you do so for the rest of the graph, you will get a nice curve like this one. So this is, you want to see the trend whereby is your CV is reversible or not, whether it can retain the shape or not. Okay, so this graph is important in order to identify that. Okay, after you already plot cyclic voltammetry at different scan rate, we're going to analyze in terms of value or in terms of quality. So the quality of the CV, what you're going to do, you need to plot the bar chart or the line graph. So depend on you what you're going to plot. In this case, it shows that at 5 millivolt per second at low scan rate, the specific capacitance is the highest and it drops upon increasing the scan rate, because at higher scan rate, the electrolyte doesn't have enough time to penetrate the surface and the bulk of the electrode material. So you can see the trend and you can discuss the trend. So how to do this graph? Let's go back to the Excel. So from the Excel, what you're going to do is you need to have the formula. For specific capacitance CSB, the formula is the area divided by mass times scan rate times potential window. Okay, that's for 3 electrode system. So area divided by mass times scan rate times potential window. So the mass, you need to weight your sample. Either you use the gravimetric mass or areal capacitance, which is the surface area. Okay, for scan rate, you need to use ampere. Uh, you need to use the scan rate in volt per second, and potential window is your voltage apply. For example, your potential window 0 to 0.6, so you put 0.6. Okay, then for the area, it's quite tricky for the area. You need to get your area from the origin. Okay, for example, let me show you that we already have one example. Okay, we already plot this graph. Okay, how to get the area under the CV curve? First, what you need to do, go to here, click the graph and go to the analysis. So here you can choose mathematics. Okay, from this mathematics button, go to the integrate, and after that, open dialog. Okay, then this interface will goes up. So what you're going to do, just click here, Mathematical, you can choose either mathematical area or absolute area, but you need to make it consistent. And then click OK. When you click OK, this area will be calculated 0.1679. So you just click Control Copy and go to your Excel, and you can just paste here. Okay, the area of your graph. Okay. In this case, the area is 1 point something. So you just need to plot. Okay, because it is quite different, because this graph we plot the current density versus voltage. Okay, let's see what if we just plot the current versus wait a minute, the current, the voltage versus current only. So here you can plot first. Okay, from here we need to click analysis, mathematics, and then integrate. Open dialog. Okay, choose here is the absolute area and click OK. So you got 1.34 times 10 to the power negative 4. So when we compare, it is correct, 1.34 times 10 to the power negative 4. Then you need to do for the rest of the scan rate. So when you do the rest of the scan rate, you get the full results. You can plot the bar chart. So here, I already plot the bar chart. See, you can see the difference in specific capacitance. So based on these two graphs, this graph you can discuss in terms of the shape, the behavior of the electrolyte. But in terms of performance, you need this graph to see the trend in specific capacitance. So what happened when you increase the scan rates means that what happened to the electrolyte when voltage per second that you supply is higher. Okay, I think that's all. Thank you very much.